Hello everyone, Jeff here. Let's do some practice from section 1.1 together. This question is asking to consider the function f, which is defined here and drawn here, and its graph given to the right, and it's asking us to find some limits. First, it is asking us to find the limit of this function as x approaches -2 from the left-hand direction. X equals -2 is here on the graph. If we are going to approach it from the left, it means we're going to start over here and move our way this way. If we look at the actual function, if we start to the left of -2 and move toward -2, the function is moving towards -4. So that does have a limit. It is equal to -4. Fantastic. It is also asking us to find the limit as x approaches -2 from the right. This is a continuous function here. We're going to get the same answer, but approach x equals -2 from the right means start at a point like over here and move this way. If we look at the function, we can see that we're again going to approach a functional value of -4. This exists. It is equal to -4. Excellent. This is now asking for the limit as x approaches -2 without a directional. We have a theorem that tells us if the limit is -4 as we approach from the left, and the limit is also -4 as we approach from the right, then the limit is -4. The limit from the left exists, the limit from the right exists, they are equal to each other, so the limit without a directional is equal to that same thing. Fantastic. Let's move on. Here, it is actually asking about a limit as x approaches 1, which is a discontinuous area here. It is asking as we approach 1 from the left. Here is x equals 1. As we approach from the left-hand side, the function is approaching 4. It does not matter what the function actually equals at x equals 1. If we come toward x equals 1 from the left-hand side, the function is approaching 4. The limit does exist. It is equal to 4. Good job. And it's now asking for the limit as x approaches 1 from the right. Here we might start at a point over here and move towards x equals 1 from the right. The function is approaching 0 as we do that. So the limit is 0. You might guess that the next question is going to ask us what the limit is as x approaches 1 without a direction sign. When we approach x equals 1 from the left, we get an answer. And as we approach from the right, we get an answer, but those answers are not equal to each other. So the limit as x approaches 1 doesn't exist. When you get different answers approaching from different directions, the limit without a directional does not exist. Nice work. And we'll do one more here. Don't forget we got the little magnifying glass in the upper right-hand corner that lets us see things a little better if we need to. We have the graph G shown. It's asking about as x approaches -1 from the left. Here is x equals -1. We've got a bunch of things going on here. The only important thing is what is happening to the function as we approach -1 from the left-hand side, which means starting from over here and moving toward -1, x equals -1. As we do that, the function is approaching 0. It does not matter that the function is actually equal to -1 at -1, or that there's this other open point at -2. As we approach -1 from the left, we approach 0 on the function. It does exist. It's equal to 0. Excellent. One more here. We have this graph of h. It's asking about the limit as x approaches -3. X equals -3 is here, and it is asking for the limit, and it doesn't have a directional, but we still need to check them. So we will look from the left and from the right, even though there are not those intermediate questions, we still need to do them. As we approach x equals -3 from the left, the function is approaching 1. And as we approach -3 from the right, the function is approaching 1. So the limit will exist, and it is equal to 1. Notice again, doesn't matter what the function actually is at x equals -3. It's 2, but that doesn't matter. As we approach -3 from either direction, the function is approaching 1. Good job.